All right, guys, this is Mrs. Lyons, and here we go with some stoichiometry. And I'm going to write my mole map right up here at the top of my paper so that I can refer to it. All right, so remember my mole map, we start with grams of our known. We can then convert to moles of our known by using the molar mass. Then we can convert to moles of unknown. So that's what we're looking for. We use the mole ratio for that. And then finally, we can go from moles to grams of our unknown using the molar mass again of the other compound. Okay? Always going to have to balance our equations first. So I'm going to do a 3 and a 2. All right. So if you look at this problem, we're always going to be looking for your known and your unknown. Okay, and that's how you're going to really know that you're on the right track, especially with units. Okay, so the known is always going to be the thing in the question with the number. So our known in this case is 4.6 moles, and it's moles of NH3. It's really important to write the units and the substance. Okay. And then what we're looking for, I'm going to look for the question word. So how many grams of nitrogen gas? So my unknown is grams of nitrogen. Now, make sure you look in the chemical equation because here nitrogen is N2. Okay, so you've got to have that diatomic piece. Okay, so I'm going to start with 4.6 moles of NH3. Okay, now if you look at your mole map, you're not starting all the way back here with grams. We actually get to skip this step, and we're going to start right off the bat with moles of NH3. We're going to put that over 1. Okay, now I'm going to have 2 conversions. Each arrow that I see in my mole map tells me I have a conversion factor. Okay. So the way that I figure things out is I use the down and diagonal to figure out what's on the bottom, and then I look at my mole map for what's on the top. Okay, so I'm starting with moles of known, okay, moles of NH3. The next step is moles of unknown. So my unknown in this case is N2, is what I'm looking for. All right, so I'm going to have moles of N2 on top. All right, and I'm going to bring these units down in diagonal, so moles of NH3 on the bottom. And like I do in class, I'm going to go ahead and just set this up, and I'm going to put all of my units in, and then I can go back and kind of know what numbers I need. Okay, so I'm going from moles of unknown. The next step is to go to grams of unknown. So in this case, grams of N2. All right, and again, I'm going to bring these units down diagonal, so moles of N2, okay? And now that I have all my units, I'm going to look at what I need to do for numbers, okay? Anytime you have moles over moles, this is the mole ratio, okay? It's the ratio of moles of nitrogen to moles of NH3. So I'm going to look at my balanced chemical equation. Moles of N2 is going to be 1, and moles of NH3, the coefficient is 2. Okay, so that's the only place you're going to use the coefficients from the balanced chemical reaction. Okay, now over here, I have the molar mass. Okay, so the moles are the grams of nitrogen over moles of nitrogen. When we're looking at this, moles is always going to be 1. All right, and then for nitrogen, we're going to look at our periodic table, which here we go. We're going to look at our periodic table, and we're going to find nitrogen. The molar mass of nitrogen is 14.01, all right? But I have 2 of them, so that's going to be 28.02 grams of nitrogen, okay? So now I'm going to plug this into my calculator, and I'm going to do 4.6 times 28.02. And then I'm going to divide that by 2. and I get 64.45. And this is going to be grams of N2. It's whatever we end up with on the end of our problem. Okay, so let's look at another one. Okay, number 2 says the lab tech has 30.76 grams of hydrogen gas. So that's our known. 30.76 grams of, again, look up here, hydrogen is H2. Okay, and then what we're looking for are unknown. I look for the question word, how many moles of NH3? So question mark, moles NH3. Okay, so now I'm going to set this up. Okay, now look, I'm starting with grams and I'm ending with moles. Okay, so if I look up here at my mole map, I'm starting with grams. Okay, I'm going to go to moles of known, and then I'm ending at moles of unknown. So I don't need that last step. Okay, so let's set this up. 30.76 grams of H2. That is always going to be over 1. And again, I have 2 steps that I need to put in here. Okay, so I'm starting with grams of known, so grams of hydrogen. Then I want to convert to moles of known, so that's going to go moles of H2 is going to go here. All right, and then I'm going to bring these units down in diagonal, so grams of H2 here. All right, the next step, so I've gone from grams to moles. Now I need to go to moles of unknown. So that's going to be moles of, in this case, NH3. Okay. Down in diagonal with my units, so I'm going to bring moles of H2 down here. All right. Now let's plug in some numbers. Okay. When I have moles and grams, I'm talking about the molar mass. So that's 1 mole has a mass of, so hydrogen has a mass of 1.01, all right? But we have 2 of them, H2, so we're going to do 2.02, okay? And then here I have the mole ratio again, moles of NH3 to moles of H2. So I look at my balanced chemical equation. So 2 moles of NH3 to 3 moles of H2, all right? So now I've got numbers everywhere. Let's do a little calculating. 30.76 divided by 2.02. Then I'm going to do times 2 divided by 3. All right. And if I do that, I get an answer of 10.15 moles of NH3. Okay. So that is the answer there. So let's try one more of these together. All right. So the lab tech uses 2.2 moles of nitrogen gas. How many grams of NH3 can be made? Okay. So I'm going to start. My known is 2.2 moles nitrogen gas, so that's N2. Unknown is going to be grams of NH3. Okay, so if I look at my mole map real quick, okay, I'm starting with moles of nitrogen. So I'm going to skip that first step. I'm going to start moles of known, and then I want to get to grams of NH3. So I'm going to do 1-2 conversions. Okay, so let's look at this. 2.2 moles of N2 over 1. Okay, now I have to flip back and forth. My mole map, so I'm starting with moles of known. So I'm here. So my next step is to go from moles of known to moles of unknown. So moles of unknown is going to be, unknown is NH3. Let me slide this up. Moles of unknown, or unknown is NH3. So I want moles of unknown on the top. I'm going to bring moles of N2 down in diagonal. And then I have one more step, right? And what I'm going to do is I'm going to go from moles of unknown to grams of unknown. So my last unit here is going to be grams of unknown, which is NH3. Units down in diagonal, so moles of NH3 go here. All right, so now we need some numbers. So if I look, I've got moles of NH3 to moles of N2. So that's where I need my coefficients. So let's see. Moles of NH3 is going to be 2, and then moles of N2 is going to be 1. So let's go down here. So moles of NH3 is 2, moles of N2 is 1 from the balanced chemical equation. Okay. So now, this last bit, I have grams of NH3 and moles of NH3. So when I've got it with grams, moles is always 1. When I've got grams, I have to look at my periodic table. So I have grams of nitrogen. So 1 nitrogen, 3 hydrogen. All right, so nitrogen is 14.01 and oxygen is 1.01. So I'm going to do 14.01. Let's do this. So 3 times, I've got 3 hydrogens, 1.01 plus 14.01 gives me 17.04. Okay, so now I'm going to multiply across the top. Notice I have all 1s on the bottom, so I don't have to divide by the bottom. Well, let's see, 2.2 times 2 times 17.04 is 74.98 grams of NH3. All right, and there you have it. That is just some examples of how to use the mole map to solve these stoichiometry problems. Let me just point something out on the back side of this. And you know what, maybe we'll do another one of these, just because it's a little bit different and I want to make sure that you've seen everything. So we're going to do number 8. All right, and number 8, first we've got to balance. So I'm just going to balance this real quick. All right, number 8 says, how many moles of O2, so that's my unknown, can be produced by reacting 12 moles of KClO3. So my known is 12 moles KClO3. Okay, and then my unknown is how many moles of O2. Now, notice what I've got. I've got moles to moles. So let's flip back to our mole map for just a minute. All right. So I'm starting at moles of known, and I'm ending at moles of unknown. So this is literally one conversion. Okay. So let's look at that. So I have 12 moles of KClO3 over 1. And then I'm looking for moles of O2. So I'm going to bring units down in diagonal. So moles of KClO3 on the bottom. And then on the top, we're going to have moles of O2, what we're looking for. Okay, moles of unknown. So now I just need to balance my balanced chemical equation, my coefficients. So oxygen is 3 and KClO3 is 2. All right, so I'm just going to do 12 times 3 divided by 2, and I get 18. So my answer is going to be 18 moles of oxygen. Okay, so hopefully that helps you kind of get a good look at how we solve these stoichiometry problems, how many different types of problems we can solve if we use our mole map to kind of direct us where to stop and where to start. All right, have a wonderful rest of your day, and I will see you in class.